What if I told you that the future of AI isn't being built in some sterile lab, but in the chaotic, amazing worlds of video games? Today, we're going to dive into Google DeepMind's incredible project, SIMA 2. It's an AI that's learning to think, to act, and even to partner up with us humans, all from inside the game.
Look, forget about AIs that just, crush you at chess or Go. We're talking about something totally different here. Imagine a real gaming partner, an AI you can actually talk to, brainstorm with, give these big open-ended goals to, just like you would with a friend. But as cool as having an AI co-op partner sounds, the real goal here is, well, it's way more ambitious. DeepMind is using video games to try and crack a problem that's been a massive roadblock for AI researchers for decades.
So to really get why SIMA 2 is such a huge deal, we need to talk about a pretty surprising weakness that even the most powerful AIs have. It sounds like a no-brainer, doesn't it? Writing a novel, that takes creativity, language, all this complex thought. Any toddler can navigate a messy room, but for an AI, that room is the real challenge. And this is where we run into a really fascinating idea in AI. It's called Moravec's paradox, and it's this totally weird upside-down view of difficulty. Things that are hard for us, advanced math, complex logic, that's a piece of cake for a computer. But the stuff we do without even thinking, like just walking across a room, picking up a cup, basically understanding the physical world around us, that's where AI really, really struggles. So, how do you teach an AI to master the physical world? Well, you give it a body and you give it a safe place to practice. And that's exactly what Google DeepMind is doing. They've created what they call an embodied agent, and its playground, its entire universe for learning, is the massive digital landscape of video games.
And this idea of embodiment is absolutely crucial. The AI isn't just some passive observer looking at a screen, it is inside the game world. That avatar you see on screen, that's not just a puppet, it's the AI's body. It's how it sees, how it moves, and how it experiences everything.
And how does it interact with this world? The same way we do, with a keyboard and a mouse. It has to learn that pressing W makes it walk forward, that clicking the mouse can open a door or swing a sword. It's learning to translate its digital thoughts into actual, physical actions inside the game's world. But here's where SIMA 2 really starts to shine. It is not a one-trick pony that's only trained on a single game. To become a true generalist, it gets thrown into this whole universe of different games, and every single one has its own rules, its own physics, and its own goals. So, in the brutal Viking-inspired world of Valheim, it learns to survive. It has to figure out how to chop wood, craft tools, build a shelter, and fight off monsters. Every single decision matters, and it's learning the hard lessons of cause and effect. And then, for a complete change of pace, it's dropped into the absolute mayhem of Goat Simulator 3. Here, the goal isn't survival, it's just pure experimentation. It's learning to navigate a world that's governed by ridiculous physics, a world where literally anything can happen. And then you have games like Satisfactory, where it's all about the long game. The AI has to learn resource management and incredibly complex spatial reasoning to design and build these huge, interconnected factories. It's learning to think not just moves ahead, but hours ahead. So all of this super diverse training has led to a huge leap forward. The first SIMA was basically just a follower. It could take simple orders. But SIMA 2, well, it's built on Google's powerful Gemini model. That's their family of AI models that can understand text, images, video all at once. And it is something else entirely. It's a partner. And the performance jump from that first version is massive. We're not talking about some small, incremental improvement here. SIMA 2 is a major step forward, and it's closing a huge chunk of the gap to human-level ability on these really complex, open-ended tasks in these games. This is what that partnership actually looks like. A request like this sounds simple to us, but for an AI, it's incredibly complex. It has to understand what you mean, visually search the world for something that kind of matches a vague description, figure out how to interact with it, and then report back to you in plain English. The difference is just stark. SIMA 1 could follow a simple command like, go to the campfire. But SIMA 2 can take a much vaguer goal, figure out all the steps it needs to take to get it done, and even explain its plan to you. It's the difference between a simple tool and a thinking teammate. But, and this might be the most mind-bending part of this whole thing, SIMA 2 doesn't just learn from the data we give it.
it can actually teach itself new skills completely on its own. It does this with this really clever 3-part system. You can think of it like a little training team. One AI acts as a coach, and it just dreams up new challenges for SIMA 2. Then SIMA 2, the player, gives it a shot. And a third AI acts as a referee, scoring the attempt and giving feedback for the next try. And the results are crystal clear. As this self-improvement loop keeps running, SIMA 2's performance in a totally new environment just gets better and better and better. It is literally learning and improving all by itself with no new data from us. So what's the big picture here, right? Why pour all of this incredible research into teaching an AI to play games? Because the skills it's learning, navigating complicated spaces, planning, interacting with the world, those skills are meant to be transferred out of the game and into our world. To push this to the absolute limit, the researchers threw SIMA 2 into the deep end, completely new, photorealistic worlds it had never seen before, generated on the fly. And amazingly, it could still find its way around and get tasks done. This ability to generalize, to take skills from one place and apply them to a totally new one, that is the holy grail of AI research. And that brings us to the ultimate goal. All of these skills, the physical coordination, the spatial awareness, the ability to understand and follow complex instructions, they're all being perfected in the safe, infinitely repeatable world of video games, with the goal of one day putting them into physical robots that can help us out here in the real world. It's a pretty profound thought, right? By using video games to solve this fundamental problem, we might be taking the first real steps toward creating AIs that can truly understand and operate in our physical world. Which leaves us with one last fascinating question to think about.